Hi class, I want to take you through question 1 from the chain rule, exercise 6.06, and just do some explanation on how to go through those questions. So if you read the notes, the chain rule, it's a really useful differentiation tool. It can be used when we have an equation that looks like y equals, and we usually have a set of brackets with a function on the inside. For example, I might have the function 2x plus 1 and brackets are closed, and then there'll be a power up here. It could be usually not equal to 1, so 2 or higher, or sometimes less than 1, so minus 1. Could be also a fractional indice for square roots, and we'll have a look at one of those a little bit later. But let's say we had a function here, y equals, in brackets, 2x plus 1, all to the power of 3. This here is a little rule. Now this appears on your formula sheet, so any assessment task that you ever do, you'll always have this handy. But trust me, the chain rule is probably one of the easiest differentiation procedures to remember. It looks a little bit foreign here at the moment, but there's really these 4 parts. And what it's saying here is this n, whatever this power is, this is our n. So in this case, it's the 3. So what we're going to do, just like we have done in other differentiation bits, we're going to subtract 1 from that. So the part in the brackets here won't change. It'll still be 2x plus 1. We're going to subtract 1 from the power. So instead of a 3, that will become a 2. This 3 comes down the front, and this n here is just whatever this power was. So there'll be a 3 here. And then this last bit here, this function dash x, is what's the first derivative of the function that's inside the brackets. And so the function inside the brackets here is 2x plus 1. The derivative of that is 2. So at the front of the brackets here, we're going to have 3 times 2, which will become 6. This will never change in the chain rule. The inside the brackets here, that function will stay consistent from the question right through to the answer. And lastly, this power has just been reduced by 1. So with the function 2x plus 1 all to the power of 3, the first derivative, or the derivative function, will be 6 outside of 2x plus 1 all to the power of 2. So let's go through some examples using that from exercise 6.06. Here's question 1, A, B, and C. So if we go through this procedure, the first derivative of this function, well, first of all, I'm going to write the function in the brackets here, because that will not change. We're going to subtract 1 from that power, so instead of a 4, it'll become 3 in the first derivative. The 4 will jump down to the front, as well as, and I'm going to put a point here just to mean multiplication, rather than write the time symbol. The derivative of the inside of this function, so the derivative of x plus 3 is 1, so there'll be a 1 down the front here. 4 lots of 1, well, it's going to be 4 x plus 3 all to the power 3, and there's our first derivative. Again, just highlighting the fact that this function here hasn't changed, and all we've really done there is taken the 4, popped it down the front, and then also multiplied by the derivative of the inside. That's the chain rule. dy dx. I'm going to first of all write down the function because we know it won't change. The 3 will come out the front. This will be subtracted by 1, but also at the front with this 3 will be the derivative of the inside. Have a think, what's the derivative of 2x minus 1? And if you said 2, you are correct. 3 times 2, well, that'll be 6 outside of 2x minus 1 all squared. Question 3, there's a function here, 5x squared minus 4 all to the power of 7. Our first derivative. The 7 will come down the front. We're going to multiply by the derivative of the inside here, a little bit more complicated. Derivative here, the 4 will disappear, and our derivative will be 10x. So we're going to have 10x out the front here. Inside the brackets, that will not change, so it'll be 5x squared minus 4, and we're going to lose 1 from this power, so we'll have 6. Tidy that up, and our first derivative will be 70x. 5x squared minus 4 all to the power 6. Moving on to D, E, and F. Hopefully you're getting the hang of this now, so I'll start to speed up a little bit. dy dx. The 6 will come out the front. It'll be multiplied by the derivative of the inside, which is 8. 8x plus 3, and we'll subtract 1 from the power. Tidy that up. 6 8s are 48. 8x plus 3, all to the power 5. Part E, dy dx. 5 will come out the front, multiplied by the derivative of the inside. Now it's minus, there's a minus 1 there, so the derivative will be minus 1. Be careful with that one. 1 minus x in the brackets, and we'll lose 1 from the power, so that'll be 4. Tidying this up, 5 lots of minus 1 will be minus 5. Oops, 1 minus x, all to the power 4. And part F, dy dx. Now there's a coefficient here, so we'll just have that out the front. The 9 will come out the front as well, so there'll be a 9, and the derivative of the inside, 5x plus 9, that'll be a 5. The brackets here, 5x plus 9, and we'll lose 1 from the power, which will be 8. If we tidy that up, through 5 lots of 9 is 45, 3 lots of 45 is 135, 5x plus 9, all to the power of 8. Slightly more challenging questions. Now I didn't ask you to do these on Friday, but I'll get you to have a look at them today. Using the chain rule on a function like this that has a square root, first thing we have to do is use brackets here and change that to a power, so that'll be 3x plus 4, and we know square roots are to the power of a half. And if we then use the chain rule on this, dy dx, the half will come out the front, multiplied by the derivative of the inside, 3x plus 4. Now we're going to subtract 1 from this power, so that'll become minus 1/2. So we've got a negative power, that'll mean it'll go at the bottom or the denominator of a fraction, and the power will be a half, so it'll be a square root of this function in the denominator. At the front here we've got 3 over 2 as a fraction, so I'll just do this in 2 steps. We're going to have 3 over 2, and we're going to have 1 over the square root of 3x plus 4. So just this section here, this is this function, the half will be a square root, and the minus means that that square root will go at the bottom of a fraction. We can then bring these two parts together. The 3 will go at the top, the 2 will just sit out in front of the square root there, 3x plus 4. For Q, I'll just change my pen colour here. For Q, it's written as a fraction. Now, there's a rule called the quotient rule we'll look at in a couple of lessons. You wouldn't use it on this, but you do use the quotient rule for fractions. But for this one here, first thing we're going to do is change it back into this form. What power will we put here? Well, if you guess minus 1, you'd be correct. So if we go through the chain rule for that function, the minus 1 will come out the front, the derivative of the inside, which will be 5. This function won't change, and we'll subtract 1 from the power. And if we tidy that back up, the coefficient here, we're going to have minus 5. The consequences of the minus power here means we're going to put this function at the bottom, and you guessed it, it's going to be squared. And there's our first derivative function. Last example we'll go through is R. If we write this, so we've got a 4 at the bottom, so we're going to put that to the power of minus 4. Our first derivative function. Go through the procedure of the chain rule. The minus 4 will come out the front. The derivative of the inside will also come out, which will be 2x. The x squared plus 1 won't change. We'll subtract 1 from the power, so we'll get minus 5. And now we can tidy that up. That'll be minus 8x. And the minus 5 here means we'll have this function, x squared plus 1, all to the power of 5 in the denominator. That's question 1. Some of the easy ones, some of the hard ones. I hope that's helped. If you haven't completed that exercise yet, use this video, go back and practice those, see if you can build on your speed.